Hi, fourth grade friends. All right, we're going to get to the math that we were supposed to do yesterday today. So we'll start with correcting our homework from the other day. So from Tuesday. Yep. So go ahead and find your book, page 775. You had problems 1, 2, and 6 on the front. All right. Number 1, you definitely needed at least angle ABC or angle CBA, I would take. But you need that little angle sign in front. We talked about that, okay? Then bonus point might have said to say this is an obtuse angle, telling me the type of angle. Number 2, you might have said line, but we talked about why this would be a straight angle instead of a line. Do you remember? Because it has those 3 points on it. That makes it a straight angle compared to if it just had the W and the Y for a line. So you might have said angle WXY or angle YXW. Either one would be good, but not line WXY, because if we have 3, then it's an angle. Number 6 wanted you to find 2 acute angles. Ones that they found were angle FEL, and we talked about how you could flip that too. You could do angle LEF. One that they found was angle CEL, or you could have done angle LEC. Those are the only 2, well 4, I suppose, naming wise, that we could find in our class when we went over this. But again, when you're naming them, it's important that you have that angle sign right there in front of it. Then on the back, you needed to just do number 8, using this picture, naming 2 obtuse angles. We could have done angle BCA or angle ACB. That would be an obtuse angle. Another one that they found was angle DCE or ECD. We talked about we couldn't do DCEF because that's 4 points. It has to be 3, and they have to be right in a row. So we couldn't do angle DCF because E would be in the way. And that wouldn't be just one angle. That would have 2 different points, 2 different rays meeting. So that one wouldn't work. And I think those were all the obtuse ones that we found then. And you could do the backwards ECD. I don't remember if I said that. Okay. Well, then today, fourth grade friends, we learned how to use our new tool called the Protractor. Okay? So we have this super cool tool to use to help us kind of learn how to measure angles, because we got a good eye for telling if it's obtuse, acute, right, or straight. But now we're going to use tools to help us figure out exactly its degrees. So you just take a moment and get your protractor. And then I want you to just kind of observe it. Just taking a look at this way. This side, maybe you flip it over because you notice the numbers might be backwards. Just take a look at your protractor. What do you notice about it? Pause the video while you observe and didn't notice any patterns or anything like that. All right, we talked a lot in class how there were holes on the top and the bottom part. It looked like a ruler down here and in that middle part too. And we noticed it has a lot numbers, but a lot more little ticks than there are numbers. A lot more lines, we said. And we also noticed how the numbers from the left to the right on the outside go from small to big, and how from in the inside they go from big to small. And if we go opposite, they go big to small, small to big, and big to small on the outside. We also noticed that it stops at number 170 on both sides. But we know that there really is another big line down here. And we remembered straight angles were 180 degrees. So we inferred that this next spot all the way down here would be 180, or 0 on the opposite side. because it's the start or the very end. Perfect. Well, we're going to go over how to use this protractor tool today. So we started with this page and we cut it out and glued it into our notebooks. So we're talking about let's measure an angle. Okay, so when we're using it, we want to think to ourselves, am I using the inside or the outside numbers? Like you notice, it has both. So we're going to find where the bottom line crosses to 0. We want to pay attention to the way our angle is pointing. If it's pointing to the right side, we're going to use the inside number. So practicing reading this one, I'm going to zoom it in a little bit. I would count up from 0 until I get to the other side of my protractor, the other side of the angle. So what I do is 0, and I notice I'm using the inside numbers. They're going up, and it's pointing straight at the 100. I know to use the inside part. To write this, I record my number, 100, and then I do a little circle up above to mean degrees. Now I think through my kinds of angles that I know. Looking at this one, I'm thinking in my head, this is obtuse. So that makes sense that it's 100 and not 80. Because if it was 80, that's smaller than 90, which is smaller than a right angle, which would make it acute. So it makes sense that this angle is obtuse. But sometimes our angles point to the left, and that's okay. That's why we have numbers on both sides of the protractor, so we can use it no matter which way our angles point. So we line it up and we read it. This time we're using the outside numbers. So I follow the outside numbers until where my arrow points, while this angle opens all the way up to 100 degrees also. Now, just to make sure I'm thinking through what kind of angle this is. Oh yeah, this is an obtuse angle. And that makes sense again. Okay? So it doesn't matter which way it points. We got the same measure because it's the same angle. It's just pointing different ways. All right, so go ahead and put this worksheet on your notebook and then get a new page and get this worksheet that you had attached glued into your notebook. Now you're actually going to get a chance to practice with your protractor. So pause the video while you gather your protractor, cut and glue this into your math notebook too. All right, so there's a few simple steps when we're measuring. The first thing we want to do is use a benchmark, meaning think of an angle in your head. We want to think, is it more or less than 90? And we talked about 90-degree angles looked almost like the letter L. And we were thinking, was it less? Was it smaller than that L? Or was it more? Was it greater than it? Like it was kind of slanting sideways. Okay, so we're picturing that in our head. So looking at this one, I'm thinking this is less than a right angle because it's smaller. So in my head, I would think acute, and I might want to write that until I get more comfortable naming my angles. So now I'm going to line my protractor up. So the center point of the protractor is at the vertex of the angle. Another word we said for vertex was point. So on my protractor, there's this little hole right here, kind of in the middle of the ruler part. I can almost hold my pencil through it. What we're going to do is line that hole up with our point. Our point isn't up here. Our point isn't over here. Our point is where those two rays meet. Now, looking carefully, on my protractor, it kind of looks almost like a letter T. We want that T, one side of it, to line up with our ray. So is that lined up with our ray right there? Nope. What about that? Nope. This is kind of close, but we want it as straight across as it can be. Okay? Then we would follow it along. But before we do that, we learned a trick in class. We said we're going to use that ruler edge of our protractor. We're going to line it up on the arrow. And we're just going to extend it a little bit, not too far, nothing crazy, so it's easier to read. So I line my protractor up again. That line lined up, that point as best as I can. Get it lined up. Perfect. There we go. All right. So now I'm thinking through an acute angle. Is going to be small or big? Small. So I'm using my smaller numbers between the two. So I follow it to where it's open and I follow this line out. Well, it's pretty much right between my 60 and my 70. And we know we're following it from 0 up, so it's past 60 and not to 70 yet. So between 60 and 70 would be 65. So our angle here is 65 because it was exactly, see how it lines up on that slightly longer line? We know it's exactly 65 degrees. So let's do that again. Let's try one more together. Let's extend this part of our angle, this ray. Stretch it out. Good. Now, we're going to line up our point and our line as best as we can. Good. All right, so now we know this kind of angle was obtuse. So we know it's got to be bigger than 90, that benchmark. We have it lined up. Now we're going to read it from 0, because it's pointing to the right, 0, all the way around. Well, there's 100, but it's past 100. How many past 100 is it? 1, 2. So we would say this angle measures 102 degrees. You try these next 3 for me. Pause the video while you extend your rays, remember? Stretch them out as straight as you can. Measure and record. Extend, measure, record. Extend, measure, record. And unpause the video when you're ready to see those answers. Okay, so for this one, we should have gotten around 48 degrees. We talked about if you are really close, like if you had anything from, we said like 44 through 51 or 52, that's what we said, 52 degrees, we would take that. Sometimes we need a little wiggle room with measuring because it could be just slightly off, but it should be as close to 48 as we can. All right, for down here, we measure this guy. All right, we know that this is an obtuse angle, so it's going to be greater than 90, so we want the bigger numbers. Line it up. All right, I follow it, and I see it's not quite to 140, so I count backwards then. 139, 138, 137. It looks to me to be at 136. But if you got anything from 134 through 139, I would accept for this one. Close to it, as close as you can. Okay, all right, then let's try this one. What kind of angle is this one? It's acute, remember, so it's going to be smaller. It's acute. All right, so we measure it out, line it up. All right, well, we see it is just shy of that 25, so I would say 24. but I would expect anything from 22 degrees through, we'll say 26, give or take 2 on either side, getting as close as we can. Okay. And that was all we did in math today. And tomorrow we'll do a little bit more measuring, and then we'll start on how to draw these angles using protractors. We'll start to use it as almost like an art tool. It's pretty cool. All right. Talk to you soon. Bye, mathematicians.